Last time you saw why inserting at the front of an array can force thousands of elements to shift. What if there was a data structure where that same insertion cost almost nothing? There is. It's called a linked list, and it fixes the exact weakness arrays have. Arrays are fast to read but expensive to insert or delete in the middle. We covered that in the last two videos. Linked lists flip that trade-off entirely. Today we're covering how they actually work, and the three main types you'll run into: singly, doubly, and circular. Instead of storing values in consecutive memory slots like an array, a linked list stores each value in its own separate node, scattered anywhere in memory. Each node holds two things: the value itself and a pointer and address, telling it where the next node lives. To insert a new node at the front, you don't move anything. You just create the new node, point it to what used to be the first node, and update the starting reference to point to your new node. Two pointer updates, that's it. O1, regardless of list size. Here's the trade-off. Because nodes are scattered in memory instead of sitting next to each other, you can't jump straight to index 5 with math like you can in an array. You have to start at the first node and follow the pointers one by one until you get there. That's ON to access an item by position. SNA, a singly linked list only points forward, node to node, one direction. A doubly linked list adds a second pointer at each node pointing backward too, letting you traverse in either direction. That costs a bit of extra memory per node, but makes operations like delete the previous node dramatically easier. A circular linked list takes either version and connects the last node back to the first, forming a loop instead of ending at a dead end. This is exactly how things like round-robin task scheduling or a music playlist on repeat work under the hood. There's no natural end to stop at. Here's the mistake almost everyone makes: assuming linked lists are just better arrays. They're not universally better, they trade one weakness for another. You gain fast insertion and deletion, but you lose fast index access and use extra memory for all those pointers. The right structure always depends on what your code does most often. Lots of reads by position favor arrays, lots of inserts and deletes favor linked lists. Linked lists store data in separate nodes connected by pointers instead of consecutive memory. That makes insertion and deletion at the front O1, but access by position becomes ON. Singly lists point one direction, doubly lists point both ways, circular lists loop back to the start. This is video 7 of the full DevVerseX Data Structures and Algorithms course. Subscribe so you don't lose the thread. Every video connects to the last. Next up, array versus linked list, where we put both head-to-head and settle exactly when you should use which.